2558 take it from the richest pile. So for this problem, let's just check what we are doing. So we are giving this gifts array, and inside of the array, for each of the second, so k is for seconds. So for each of the second, we can do these operations. First of all, we're gonna choose the pile with the maximum number of gifts. So this means for the first time, we're gonna choose this number 100. So secondly, if there is more than one pile with the maximum number of gifts, choose any. So if there's another 100, so we can choose any one of them. It is okay. And then what we're going to do, we're going to reduce the number of gifts in the pile to the floor of the square root of the original number. So what does that mean? So first of all, we're going to have this original number. And then we're going to have the square root. And then we're going to just use a floor. Yeah. So this is all the operations. So for this example, it's going to be 10. So the floor of 10 is going to be 10. Yeah, so this is exactly what we are doing. So we're going to return the number of gates remaining after k seconds. Yeah. So in this example, after k seconds, so the final array is going to become this one. And we just need to return the sum of those values. Yeah, it seems this is going to be a heap problem. And it's going to be main heap. It's going to be the max heap. Yeah, so for each of the time, basically we need to find the maximum value, and then we're gonna do the maximum value. We're gonna do the operations. So the operations are gonna be square root of this number, and then we're gonna take a floor. Yeah. Now let's just try to solve it. So first of all, let's just use the gifts. Yeah, maybe I'm gonna use the nums. So for the nums, I'm gonna use minus n. So for n inside the gifts. Yeah, so I'm going to turn all the numbers into negative values because I'm going to use a max heap. Then I'm going to heapify. I'm going to heapify those numbers. Yeah, so for how many steps? So for underscore in raise k, it's going to be k steps. So for each of the time, I'm going to pop out a value. So let's say this value is going to be num. So it's going to be heap pop. And it's going to be heap pop with these nums. And then what we're going to do, we're going to prepare this value. Yeah. So the value going to be, so this num, first of all, it's going to be a negative value. And we're going to take square root of this value. So square root of this number. So we're going to use a negative value of this num. Now this minus num going to be a positive value. And after that, we're going to use a floor. Now we're going to have this value, but we need to put a negative value inside. So this means we also need to choose a negative value. Yeah. Now what are we going to do? We just use the heap push. We're going to push this value inside of the nums. Yeah. So finally, we just need to return a negative value of sum of all the nums, because inside of the nums, it's going to always be negative values. Yeah, so this is exactly what we are doing for the problem. Because from the beginning, all the gifts is positive values. So this means it is okay for us to turn all the values to negative values. And then we can do such kind of operations. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast. And the time complexity is k log n. So the length of the gift is 10 to the power of 3, and k is 10 to the power of 3, so basically it is n log n time. Thank you for watching, see you next time.